So sample problem number 4. So given a potential difference between two ends of a copper wire, 2 kilovolts, and if the wire has a length of 200 kilometers and a cross-sectional area of 40 millimeters squared, we have to find the resistance R of the conductor. So note that the resistivity is given by 1.7 times 10 to the negative 8 ohm meter for copper. So let's find the resistance R. So to find the resistance R, so R is a constant that is the ratio between the voltage and the current of a material, and is given by rho times L over A. So are already given with rho, which is 1.7 times 10 to the negative 8 ohm meter, and L, which is 200 kilometers, divided by area. So the area is 40 millimeters squared. So we can convert this to meters squared. So we can use the conversion factor of 1 meter is equal to 1000 millimeters. So we have to square this. And by doing your conversion, we get an answer of 85 ohms. So this is for sample problem number 4. So for sample problem number 5, the radius of the conductor of a nichrome wire is 0.32 millimeters, and the resistivity is given by 1 times 10 to the negative 8 ohm meter. So letter A, we have to find the resistance per unit length. And letter B, given the voltage 10 volts and the length of the wire 1 meter, we have to find the current in the wire. So for letter A, we can find the resistance per unit length by looking at the formula for the resistance, which is rho L over A. So by rearranging the terms, you can get an expression or an equation for R over L, which is equal to rho over A. So given this expression, we already have rho, and we already have A, or we don't have A, but we can calculate for A because we're given the radius of the conductor. Therefore, rho over L is equal to rho over A, where the area of the conductor is pi r squared. So rho is given as 1 times 10 to the negative 6 ohm meter divided by pi r. So r is given as 0.32 millimeters, and we have to square that. So by evaluating this, we can solve for the value of R over L, which is 3.1 ohms per meter. So we have a resistance of 3.1 ohms per meter. So for letter B, we have to find the current flowing through the wire. So how can we do exactly that? So we know that the current from Ohm's law is equal to voltage divided by R. Okay, but we only have the value of the voltage and we don't have the value of the resistance. However, we have solved for the value of R over L earlier, which is equal to 3.1 ohm meter. So we can use this to solve for the resistance per meter. So in a length of 1 meter, so for length 1 meter, the resistance is equal to 3.1 ohm meter times the length, which is 1 meter. Therefore, we can get the total resistance in a 1 meter wire of 3.1 ohms. Okay, so this one. So this is your total resistance in a conductor of length 1 meter. So in order for us to solve for the current I, so we have to divide the voltage with the resistance. So the voltage is given as 10 volts, and the resistance we have computed for a wire with length of 1 meter is 3.1 ohms. Therefore, we will get a total current of 3.2 amperes. So this is for letter B.